In this video we're going to introduce the concept of Hess's law. So Hess's law is a chemist's version of the first law of thermodynamics. So if you studied physics you might have come across this. You'll probably come across it in year 7 at high school, but you probably didn't call it the first law of thermodynamics. It says that energy cannot be created or destroyed, only changed from one form to another. And Hess's law applies that to chemical reactions. Hess's law says the enthalpy change for a chemical reaction is independent of the route taken. So Hess's law says the enthalpy change of a chemical reaction, and the main thing you need to remember is it's independent of route. It doesn't matter how you get from A to B, you'll take or give out the same amount of energy. So why is this important to a chemist? Well, it's not always possible to find out from A to B directly. Maybe that thing is not able to be done as an experiment. Maybe the rate of that reaction is too slow, so you cannot measure it easily because the rate is slow, usually because the activation energy is too high. So that experiment is not measurable. And so we have to find a different experiment that we can do. So here's how it works. I want to turn A into B, but I can't do that directly. For whatever reason, I can't do that directly. That would be called route 1. And that's our direct route. But I can turn A into C and measure that, and then I can turn C into B and measure that. Okay? So if I know that, then I can find this different route, a less direct route that goes via C, call this route 2. Now I'm starting at A, so both arrows point away from A, and I'm ending at B, so both arrows point to B at the end. And from Hess's law says that route 1 must equal route 2. So if we look at route 1, and we remember that enthalpy changes are vector quantities, route 1 just follows arrow 1 and nothing else. And route 2, we follow it down now. We follow down, I'm just going to use my highlight so you can see, we're going to follow down this arrow, so we're going with it. So we're going to add it, delta H2, so it's plus delta H2. And then, following on with our highlight, once we get to C, we're going to carry on up here, and we're going to follow the next arrow. So we're going to add arrow 3. Therefore, if we know that 2 and 3, we can find out 1. Let's have a play around with this idea of vectors and see if we can put Hess's law into practice with some other cycles. So let's have a look at these two cycles and use our understanding of vectors to see if we could find out what that delta H1 across the top equals. So using a different colour pen or a highlighter, let's follow the path. So if we go down arrow 2, we're going to add arrow 2, but then as we come round here and we follow up, we're not following arrow 3, we're going against it. So our longer route, is following arrow 2, so we add arrow 2, plus sign in front of it, but we're going against arrow 3, so we're taking it away, because if it's a vector quantity, if we go in the same size arrow but in the opposite direction, we'll have the same number but with the opposite sign. So we put a minus sign in and we'll get the answer. So have a look at the next one. What do you reckon delta H1 equals? So we're going against arrow 2, minus arrow 2, and then we're adding arrow 3. Now some people, you might write that the other way around, 3 minus 2, just for neatness, but it doesn't make any difference. Let's have a look at a couple more. So just have a look at those two cycles, a little bit more difficult because they've got more steps. Can you work out what arrow 1 would equal in each of those two examples? So give yourself a minute, pause the video and have a look, see if you can figure it out. So there we go, at the first one we followed arrow 2, we followed arrow 3, but we went against arrow 4, so it was minus delta H4. And our second example, we went against arrow 2 but followed arrow 3 and followed arrow 4. Sorry, we went against arrow 3 and followed arrow 4. So we end up with minus delta H2 minus delta H3 plus delta H4. So this is Hess's law, and we're going to, in the next video, use some actual chemical reactions and see if we can use Hess's law to find our unknown enthalpy change.